Ready? Smiling, looking pretty, because we are going live in 5 seconds. 4, 3, 2, 1. Good afternoon, ladies and gentlemen from Noordwijk in the Netherlands. Welcome to another edition of the Epic product release. Today is a fantastic day. Well, like every day in my life, everybody says, Jose, you're always positive. Every day in my life is a fantastic day because I am the CTO of the leading, biggest and most influential photonic association in the world. So of course I live a wonderful life. But today we have products from 6 fantastic companies. This just in, we're just a few hours away from the commercial launch of 6 breakthrough products from leading Epic members. Join me live at 4 p.m. on Tuesday, November 17th and be the first to discover what's new at Asphericon, FBGS, HoloOr, TeraXion, Umicore and Luna Innovations. Stand by for action because the world is watching. The world is indeed watching. We are live in YouTube, so hello YouTubers in the world. If you have any question during the show, please make sure that you put your questions in the chat. But most important, if you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-asoc.com, jose.pozo@epic-asoc.com, and I will be more than happy to make those introductions. Thank you very much for the constant support that you give to Epic. As I said before, today we have 6 companies. We're going to start with Asphericon, that are expanding the range of UV-Aspheres. Then we'll continue with FBGS. They do shape sensing systems based on their own fiber that they actually pull from the tower in Belgium. And then we go to HoloOr to hear a bit about laser beam shapers for welding. Then we go to TeraXion. They're going to show us their new tunable pulse stretcher. Then we go to Umicore, 6 inches Germanium wafers for VCSEL fabrication, and we finish with Luna Innovations. We're going to hear about high definition distribute temperature measurements based on fiber sensors. What an amazing hour of your lives that you're about to spend. Let's go now to the capital of optics in Europe and in the world. Let's go to Jena, let's go to Asphericon, let's go to Sabrina Matthias to hear about the expanded range of UV-Aspheres from Asphericon. The floor and the attention of everyone here in YouTube is yours. We have you still muted, but this is the live show, so we are used to this. So please unmute yourself so we can hear the voice. And also let me remind everyone, Sabrina Matthias has a fantastic YouTube channel. So follow her in YouTube. She has fantastic videos there.
All right, can you hear me now?
Yes, loud and clear.
All right, yeah, Jose, thank you for the very kind introduction. And it's true, there's a new video that we just uploaded, I think by the end of last week. So you can all go there and check it out. But yeah, we are today here to introduce our latest products. And I really like to thank Epic that you give us this opportunity, because in those very weird and crazy times, this is the only platform most of our companies have to do so. So thank you again very much for this opportunity. Why is my presentation not going forward? Oh, here we go. Asphericon is a technology leader when it comes to manufacturing very special optical components for customers. But what we also offer is standard components in the range of aspheric optical components. And I'm very proud to introduce to you today a total new assortment in our range of our fused silica aspheres for the UV range. What we have done is we have completely enlarged our whole assortment by first adding new designs. Then we have added a lot more quality levels for our customers to choose from to get really the right quality level for their application needs. We also, or this implements that we have also implemented new aspheric lenses with a very low roughness. And to round this all up for our customers, we also added new coating lines for them. So what is that in detail? The optical designs that we have added are all based on 355 nanometers, so totally in the UV range. And this means we have added a lot more diameter to focal length options that our customers can choose from. So everybody will find the perfect fit for its application. And you should especially look for those UV lenses if you have an application that calls for a low thermal expansion, if you need a low dispersion, or just if you do material processings, or for most of the ultra short laser applications, this could be a very good help. The quality levels that we have added. First is the precision level. This is pretty much a standard level that is very common in the market. And this is what we call our value champion. So it's a very easy to start lens with a surface form deviation of 500 nanometers. Then we have the ultra quality, which is only 300 nanometers of form deviation. And this is about 66% above the industrial average. So it's already a lens with a very high quality performance. And last but not least, we have implemented our new industrial benchmark that rounds up the beam tuning components. And this has a very low surface form deviation. And those are also the lenses that have the very, very high or very low surface roughness. And the surface roughness is something that we wanted to implement because if it comes to applications that call for low scattering, this is what you should take care of. And low scattering is mainly asked if you would have an application that has a very high laser power. You don't want to have anything that does some backscattering. You really want to avoid this. And this is very unique in the market because those are the first off-the-shelf lenses that you can buy with such a low surface roughness for such high power laser applications. And the coatings. You might be aware of our broadband coatings that we offer, but when every photon counts, you want to have a V coating. And so we decided to also implement those V coatings. And we start with those 3 V coating lines for some very typical laser wavelengths. But this helps to find the best solution for your application. We also offer most of the lenses mounted, so it helps you to have them perfectly aligned. It makes them very high modular with all our other beam tuning components or all other components from asphericon. It also gives a more easy handling opportunity, and they are also compatible with other threads in the market. So you can also use them with cameras that you already have in your setup. What should you take home? With all the new added lenses to our assortment, we can now offer the largest selection of UV-Aspheres in the whole market that you can buy as off-the-shelf lenses. And you can really start from the value champions up to the new industrial benchmark, where we can offer this very low surface roughness if you want to use such lenses for high power laser applications. And to round it all up, we have those new V coatings available for you. So everybody should find something that fits into their applications where you need aspheric lenses made of fused silica. Go online and start shopping.
Thank you very much, Sabrina. Go online and start shopping. I really like that sentence. Also, let me remind you to go to the YouTube channel of Sabrina Matthias or Asphericon.
Yes,
I am
go
a huge
there.
fan of the beam shaping videos. But Sabrina, today you have potentially 629 companies that are members of EPIC. What can you do for them and what can they do for you? That's
this question again,
question.
Jose. I didn't expect that because I was watching the last product release show that you had online and you never asked that one. What can we do for them? As I said, with this enlarging this assortment, you now have so many opportunities, and we have counted, we have now more than 400 lens opportunities just in the UV range. So I think there should be a good fit for anybody out there who needs an aspheric lens in their setup. And we are very happy to get their requests, and we will sort out the perfect mix and match of what lenses they should use in their application. So I think this is what we can do with these new products that we have introduced here.
So as you have said in your presentation, you have broadband solutions on almost any wavelength. You are now today talking about the UV. What was the reasoning behind having a UV line and pushing it? Is there, you see a big boom in the market for the UV laser manufacturers? What was the motivation for this?
On the one hand, maybe the UV, I mean, it's not only covering the UV, but the designs are based in the UV, but the way the design, the way the team made the design, it's so nice balance that you can use them all the way up to the infrared as well. So you're not only limited to the UV, but we saw a big market for fused silica lenses because lasers are getting higher powers. So you can't just use all other standard materials. This really requests for a fused silica lens where you have the lower thermal effects in your setup. So this was our motivation to go there. And I think there's not too many fused silica lenses as off-the-shelf lenses that you can buy off the shelf, off stock in the market. That was our motivation.
We have a question from my colleague Anna Kolosowski from LPKF Laser. Anna, good afternoon. What's on your mind? I don't know if we can hear Anna, but I can read her question. Her question is, are you planning to offer V coatings for higher wavelengths like 1940 nanometers?
Say the nanometers again.
Are you
for what?
2 microns, 1940 nanometers?
Maybe not as a off-the-shelf product, but this can definitely be coded as on the request. Like you can choose one of the lenses from the off-the-shelf, and then we just code it with your special request. If we see, let's see, in 1 or 2 years that this wavelength is the booming wavelength in the market, we would definitely use this as a standard coding as well.
Thank you very much. And we have also the press in the room. So we have Oliver, who is the editor-in-chief of Photonics Views. Oliver, thank you very much for being with us this afternoon. We just heard the presentation from Sabrina from Asphericon about the UV-Aspheres. What's on your mind after this?
Hi, good evening after everyone. Nice presentation. My question was rather not regarding the industry as such, that Jose just mentioned, but how many lenses are we talking about? What's the volume and what's the market share you're going to target with it?
You mean how many lenses we are aiming to sell?
Yes.
As many as possible. Oh, that's a tough question. I haven't checked what the actual sales are on the lenses that we have. I mean, it's not that that's the first time we are offering fused silica lenses. We already have them in our assortment of stock elements, but we just enlarged this. This is a tough question. I can't answer this right now, but of course, as many as possible. You can buy the first one if you want.
Thank you very much for a great presentation. Thank you, Sabrina, for being with us, for being so epic. Let's go now to the second presentation today. We are going to go all together to our next presenter, who is going to talk to us, Bram from FBGS, is going to talk to us about shape sensing. I'm very excited about this because we love when companies manage to manufacture their own fiber and then make a difference in the industry with it. And that's the story behind FBGS. The floor and the attention of everyone goes to Belgium, goes to you.
Good afternoon, Jose. And thank you very much for the opportunity to present our shape sensing system and the recent developments we did on that side. I'm also trying to share my screen. I'm not sure if it's
you are almost there, so we can see it, but we don't see full screen. So let's do the magic. I think you just have to shift the slide, the screen that you are sharing. You are sharing the wrong one, I believe, which we'll manage to solve. I am very excited about this because especially in medical, we have seen a huge boom for shape sensing. A couple of years ago, well, like 10 years ago, Philips started making a difference on this, but the supply chain is now very strong, like company like FBGS. Bram, Tell us,
better?
how are you going to make a difference in shape sensing? The floor is yours.
Thank you very much. PowerPoint was failing on me here for a minute. So let me briefly introduce FBGS in a few words. So FBGS is based in Germany and in Belgium. We're developing and manufacturing high quality fiber brag grading products and also full fiber optic sensing solutions and all the associated components. We also have offices in China and the Americas as well. So we're actually worldwide active as a company. This is in a nutshell the different industries we're targeting. As you see, it goes quite broad: energy, transportation, infrastructure, composites, but also medical and biomedical applications are actually getting getting increasingly important for us. We see a huge interest from that industry to add sensing intelligence to all sorts of medical devices, catheters, and all sorts of surgical tools as well. In a nutshell, I mean, I think most of the people in the audience are familiar with the concept of fiber brag grading, but just to align the thoughts here a bit. So brag grading is basically a periodic modification of the refractive index in an optical fiber, as is illustrated here. That is acting as a sensing means, picking up strain and temperature effects. And the beauty of fiber brag grading technology is that it's very easy to multiplex multiple measurement points along the same fiber by assigning a different wavelength to every measurement position. It's even possible to reuse the same wavelength over and over again. So multiplexing is actually endless using this technology. And then what we add specifically, or our specific technology, is actually the combination of fiber drawing and grading inscription, as is also shown here on the right. So during the drawing of an optical fiber, we add that grading, that sensing position or that sensing means at the same time. So that's a fully automated and inline process. And also important, the primary fiber coating is only applied after the grading is inscribed. So when the fiber is coming off the tower, the gradings are inside, the coating is on, and we basically still have the pristine strength of the optical fiber maintained, so that it is not affected by the inscription of the gradings. Moving then in the direction of shape sensing, a critical component or a critical aspect are so-called multicore fibers, which are enabling that shape sensing intelligence. A multicore fiber basically consists of several active cores in the same cladding. Typically, there is one center core surrounded by 3 or 6 outer cores. We actually did now several iterations of that fiber manufacturing process, standardizing now around a cladding diameter of 125 micrometer with typically 4 overall cores in that multicore fiber. It's important to mention that the draw tower grading technology is used to, again, combine the grading inscription and the fiber drawing. That means that we then avoid fiber bundling, core-to-core inscriptions, and there is also a very minimal influence of the inscription process on the fiber strength. So the fiber itself is the sensor element, very strong, and is capable of surviving assembly processes, typical sterilization processes coming into play with medical applications. If we then take it one step further and we come to the actual product we want to present here and we are actually releasing as we speak, then we of course need to add several other building blocks to come to an overall shape sensing system. We need to connect the fiber, we need to interrogate the fiber. So we have an interrogation unit, a measurement device capable of reading out multicore fibers and interpreting the brag grading responses to translate the sensing information in the fiber and translate that into actual shape information capable of visualizing curvatures, position tracking, and so on and so forth. The pictures you see here are our off-the-shelf system we have available today. For most of our customers, we are today developing dedicated solutions, tailoring the fiber, the measurement device, and other components to make it fully compatible with the actual end use of the optical fiber. I will try to show this movie. I'm not sure how fluent that will go. Basically, what we see here is a 3D shape with a catheter, in this case inside. There is a multicore fiber integrated into that device. And what we're visualizing here on the left side of the screen is the position of the end tip of the catheter, which is pulled back. I mean, in this case, what we see here now is an offline calculation, but it's nicely linking the two measurements together. We see the fiber or the device which is pulled back and the actual shape which is reconstructed and the position of the fiber which is also captured. In the second part of the movie, you also see the more, I would say, fundamental concept of shape sensing using such a multi-core fiber. So again, the multi-core fiber is embedded here inside that catheter device. And what we visualize here is the last, I think in this case, it's 20 centimeters or so section of that optical fiber, and the real-time shape then reconstructed in this screen. I mean, this is a very basic visualization. Again, this is a plugin software we developed, can be tailored to the needs of the customer, and is then also typically combined with other feedback mechanisms and other sensing information. I will not go over all this text. I think it's important to mention that we combine the unobtrusive multi-core fiber technology and Bragg grading technology in one automated process. One of the key applications we identified is navigating surgical instruments in and on the human body. That's actually a very broad spectrum. And of course, the nature or the reason for that is that the current availability and accuracy of existing tracking tools is very limited. So we want to reduce, our customers are reducing health risks and also increasing the efficiency of different surgical procedures and then all sorts of medical procedures actually. I also would like to invite you to go to our recently launched webpage, specifically on the shape sensing technology, where you'll find out much more on the different applications we're targeting with this technology. This is an elaborate list of the different application areas where we're active in today, and in many cases we have existing development projects ongoing, working towards full solutions, typically together with these end customers. Okay, there's also more technical information, but I think I will stop here and give the word back to Jose, or if there are questions, I'm of course happy to answer and to discuss that.
Thank you very much, Bram. I love it. I love the idea that you expect a company who manufactures fibers and they tell you a whole system for shape sensing. That's fascinating. We have 629 companies here with me. What can you do for them and what can they do for you? The so-called epic question.
The famous epic question indeed. First of all, what can we do for them? I mean, as you've seen, we can offer that a full shape sensing system. Of course, here we're more targeting end users. Today, the presentation focus was on medical end users. Of course, it goes broader than that. We're also targeting energy applications, basically any fiber optic sensing case where there is a need to add curvature and shape sensing monitoring. There, I think we can play a role, and we have an interesting offer to make. What can Epic do for us? I mean, these multi-core fibers and all the miscellaneous tools around that are of course quite complex. So we're continuously looking for better connectorization processes, improved tools to work with multi-core fibers to integrate them into existing catheters, specialized tubings, and all tools and means you need to handle multi-core fibers are potentially very interesting for us to take that product then to next level, I would say.
Medtronic, Philips, Stryker, Siemens are going to listen to this. How would you tell them what is new? Because shape sensing has existed for a while. So how could you tell them what's new?
Mm-hmm. What we bring that is very new is actually the combination of so-called wavelength division multiplexing. So we use actually very specific fiber Bragg grading technology to improve the accuracy and to resolve basically the last millimeter when you track the shape and the position of the optical fiber. So actually we, by combining that DTG or that FBG technology with the multi-core fiber, we have actually a new product, which is of course different from the distributed way of measuring shape and position as some of the companies you mentioned are working on. Also on the software level and the model which is behind, we can bring a lot of added value because a lot of the know-how is not only in the fiber itself, but also on the way how you process the data, how you get out twist effects, how do you do proper referencing and so on and so forth. So actually we came quite a long way there. So I think also on that side, we have quite a lot of know-how and new things to offer to the companies you just mentioned as well.
A great partner because this is a system that can actually be integrated into any other systems and it's a product by itself. So congratulations, Bram. We have a question in the room. Bendix from Umicore, what's on your mind?
Yes, good afternoon. Yes, I'm really surprised to see that we have this type of fiber activity in Belgium. I mean, we are supplying germanium dopants for fiber optics across the world, so I'm really surprised to see that you guys have this installation. Do you make your own preforms or you buy your preforms and you just pull your fiber?
We don't make our own preforms as FBGS. We have different partners. I mean, the fiber drawing and fiber manufacturing is also happening in Jena on the German side. And the Belgium office is working on the measurement devices and the application side of things.
Okay.
Our office in Jena has close partners in the local, in the area.
J-Fiber, I guess, yeah.
Including J-Fiber, that's indeed one of them, but also other companies all around Europe and all around the world, depending on the application and the specific fiber type. But the fiber preforms as such, that's not our core expertise. We're drawing the fiber and adding the gratings while we draw the fiber. But it's good to meet you, and we can perhaps also talk offline
to meet you, Bram. Yeah, we should.
One of the great companies in EPIC is IMTech. They do backend and packaging solutions for optoelectronics. Matthias has something on his mind. Matthias, what's your question?
So well, maybe I have a very stupid question, but I'm thinking out loud, and maybe everybody talking is, you mentioned that you can use this fiber also in catheters, but I'm wondering whether it's possible to use this also for, let me say, for endoscopes, for very, very miniaturized endoscope, where you use maybe some fibers for illumination, and with a front micro lens array, for example, to apply a camera system to the unit. Is this something you have in mind?
That's one of the applications we have in mind, and we actually have some ongoing discussions on that as well. Of course, there will be probably need to then work with several fibers, each fiber having its own means. So our fiber is specifically a sensing fiber, capturing then the shape and the position. Also temperature and pressure are possibilities, but probably for that type of endoscope application, I would imagine there can be then a combination of multiple fibers to be combined together. But for sure, that's an interesting area, and we're also looking in the direction. Yes.
Okay, thanks.
Let's go all together now to the Mediterranean Sea. Let's go to Israel. Let's go to talk to Natan from HoloOr, because they have now laser beam shapers for laser beam welding. The floor and the attention of everyone goes to HoloOr, goes to Natan.
Thank you, Jose, for this kind introduction. And for those not familiar with HoloOr, we are one of the world's most, let's call it, veteran producers of diffractive optics for high power. We have more than 31 years of experience in diffractive optics manufacture. Started off with shaping for 10.6 CO2 lasers for coherent, and went up from there, covering the entire spectrum from the deep UV to the mid IR. And we basically, HoloOr manufactures, designs, and produces in Israel the diffractive optic components that go into laser systems. These laser systems can be basically anything from aesthetic treatment systems such as fractional skin treatment, through industrial systems in the macro like welding or cutting, and in the micro such as, for example, a micro LED or even smaller LED manufacturer, liftoff, scribing for solar panels. It's all done with DOEs. And for those of you that don't know, these DOEs, or diffractive optical elements, are basically thin windows that have micro and deep patterns on their surface that can shape the face to any desired profile, and then they can shape basically the intensity at the focus of the lens at the far field to whatever you want. DOEs have a lot of advantages over standard refractive optics. They have high LDTs because they're basically flat and don't need to work with high angle coatings. They have absolute angular precision. They have no tolerances on that because it's lithographic production processes, and they're also thin and compact. And we can put a lot of shaping on one surface. Basically, we can add, for example, a lens function and such shaping to a circle or a ring, plus other things like splitting. Today, I want to focus on shaping for the applications of welding and cutting, specifically for cutting and welding with fiber lasers, mostly multimode fiber lasers in the regimes of 6 kilowatts and above, mostly for automotive, but also other industries such as aerospace and shipping, etc. And basically, DOEs can shape the light of any laser to any desired shape. I mean, a lot of these shapes that we show here, such as this flat top or this racing shape, are also often used in applications of welding and cutting.
I think we may have lost the sound of Natan, which is a pity because when we're talking about DOEs from HoloOr, this is the kind of thing that they have mastered. When it comes to these high powers, developing a flat top or developing a perfect Gaussian at this high power is something that very few people have mastered. I'm very happy to have also asphericon in the room who have extremely expertise on that. And when we solve the problem with Natan, I don't know if Natan is back. 1, 2, 3, 1, 2, 3. It is not back, and I know how to count to 3 very well. Why don't we go to TeraXion, and then we come back to Natan. Let's go to TeraXion. Let's go to René, Dionne. Let's go to beautiful Canada. Here it is 4:30 in the afternoon. What time is it for you?
It's 10 o'clock, 10:30.
Good morning, time for a coffee. The floor and the attention of everyone goes to pulse stretching. Goes to TeraXion. The floor is yours.
All right, let me share the screen.
Hello, Jose. Am I back?
I'll come back to Natan in a second. Let's go to TeraXion now and come back to you.
Okay. Okay, you see the presentation?
Crystal clear.
Okay, thank you, Jose. You mentioned it. I'm René Dionne, product line manager for Ultrafast component at TeraXion, presenting our brand new tunable pulse stretchers for high energy ultrafast lasers. So
We can hear you,
Okay.
we can see you, everything works.
That's
Carry
good.
on.
Okay, this year TeraXion celebrates 20 years of sustained innovation already. And 20 years ago, TeraXion started developing several products based on fiber Bragg rating to manage chromatic dispersion in optical fibers for the telecommunication market. We then leverage our telecommunication product expertise to develop innovative component for the laser manufacturer, which now accounts for more than 50% of our revenues. You might recognize these building blocks. They represent TeraXion's overview of a third pulse amplified ultrafast laser, or CPA architecture laser. Our current offering comprises dispersion compensators for the mode lock oscillator and a whole family of fixed and tunable pulse stretchers. They stretch the pulse over time before the amplification chain. This is the first function of the CPA technique. The product we're launching today is the TPSR-Xtended, a tunable stretcher with 50% more stretching than its predecessor, about 1.2 nanosecond over 800 picosecond. The new stretchers open possibilities for high energy ultrafast lasers, such as an access to high throughput material processing. Each dot here represents a commercial laser available today. While most industrial applications are satisfied with 50 watt, 20 microjoule, the industry is pulling toward several hundreds of watts of power, several hundreds of watts of microjoule of energy. This tunable pulse stretcher allows our customer to maximize the amplifier capacity by adding 50% more energy per pulse. It can adjust the high order dispersion up to beta 5. And based on our customer feedback, the tuning feature improves the laser manufacturing yield while maintaining a constant performance for every laser produced. They even improve their laser specification. While it's common to tune the compressor to optimize the pulse quality, it adds some mechanical instabilities and limits the tuning to the second and third order of dispersion. Our customers have reached better results by tuning the stretcher. Here's an example of an almost perfect pulse coming out of an oscillator. After amplification and some asymmetry or some noisy seed spectrum in combination with cell phase modulation, this leads to a distorted pulse. By tuning the TPSR-Xtended, it's possible to rebuild an almost perfect pulse without any other adjustment on the laser. In summary, TeraXion is launching today a brand new tunable pulse stretcher that will enhance ultrafast laser performance, thanks to its increased stretching window and its higher order dispersion tuning. This is the next step in our journey to remain a key component manufacturer for ultrafast laser designers. More than a FBG company, TeraXion will soon increase its presence by bringing new technology to the market. So stay tuned. I invite you to contact me or our sales department to properly select the appropriate component for your specific laser.
Thank you very much, René, for this presentation, and also congratulations on how you are pushing the laser-based manufacturing interaction like crazy in the last months. Very, very impressive. Keep pushing that way. I love success stories. I have 629 success stories in my book. What can they do for you, and what can you do for them?
Yeah, the epic question. I was expecting that one. So, of course, at TeraXion, you can be very strong in one domain, but if you want to have success, you need to partnership with several people. So I think if we want to push further the limits of either ultra-fast or high-power lasers, you have to collaborate with other companies. And this is really what I'm looking for over the next year. I want to expand the collaboration at TeraXion with other companies doing different technology and push the technology further. At TeraXion, we're expert in filtering, we're expert in phase control, low noise laser. So we have many technologies available. And as long as we will partner with somebody else, will bring new technology to the market.
You're targeting the pulse stretching between 1 to 2 micrometers. You go all the way to 2 micrometers. For these longer wavelengths, what are the applications, the killer applications that you think they can benefit by pulse stretching?
The pulse stretching, of course, is required to get high energy, short pulse laser through an amplifier. Of course, at 2 micron, there are some welding applications in plastics or other medical applications. But yes, as long as you have to deal with a femtosecond pulses, you need to do some stretching before the amplification.
So I have in my list companies like Trumpf, like LPKF, like Conversion, like Kaplan. I could talk like for hours about them. What would you say is new?
What is new about this new pulse stretcher is, of course, the extended stretching. So it means, especially if you have a highly nonlinear amplifier that use a lot of fiber, you're sensitive to nonlinear effects, especially to cell phase modulation, which can distort the pulse. So by adding more stretching to your amplifier, you can either reduce these the SPM, or you can increase the pulse energy in your system.
We actually have a comment from LPKF Laser. They are saying that they are looking forward to talk to you for glass processing, from deep etching on glass. So there's already a connection there. Congratulations once again, René, for what TeraXion is achieving in the laser-based manufacturing world. Let's all go back from Canada, back to Israel, back to Natan, back to HoloOr. Tell us about DOEs, and especially tell us about what you were telling before the IT problem. The floor and the attention of everyone goes back to you.
Thank you, Jose. Now I need to speak twice as fast, and I talk too fast anyway. So for those of you that do not remember the start, I'll just go very quickly. Basically, my name is Natan Kaplan from HoloOr. We are the world's, I think, the most veteran company of DOE design and manufacture, especially for high power applications such as shaping of industrial lasers, including for processes such as solar panel processing, laser liftoffs of micro-LEDs, and also macro processes such as cutting and welding, which are going to be my focus today. So, like I said, yeah, sure, we can shape a lot of shapes, and many of these shapes that we can change the lasers to are highly useful for cutting and welding. So what's new? What am I showing today? So basically, today I want to show the fact that although DOEs are basically passive components, yeah, they give you a certain distribution and does not change. Their quality of shaping is, of course, the best one, much better than most active components such as phase modulators, etc. you actually can get active or adjustable effects with diffractive optics. So today I'm going to talk about adjustable shaping for cutting and welding with DOEs. And specifically, I've used this example of the ring mode, which has been shown to be very useful for welding and cutting processes. Now there's a lot of buzz around cutting and welding with ring mode lasers. And I think there are many of these from, for example, from Trumpf, from Enlight, and for at least 2 other companies, Coherent, that I know of, that they offer these fiber lasers for cutting and welding that have both the core mode and an extra higher modes with more power. And there are quite a lot of publications showing that this gives you better keyhole stability, less splatter, and generally a better weld quality. Now, all these solutions are very fine, but they usually require a specific laser. I mean, you need to use the specific sort of fiber coupling laser, which is probably high cost. And also, they all have fast switching, but generally for many applications in cutting and welding, it is not needed. You just work on a certain workpiece, and when you go to a different area, you need switching in the timescales of, I don't know, hundreds of milliseconds, not much better than that. So for that, we have a solution based on diffractive optics, which is basically the idea of using a diffractive optics sub-aperture element, which has a part of the aperture having a diffractive pattern that generates, for example, in this case, a ring, while the other part of the aperture generates, in this case, 0 order. It could be a different shape, for example, another ring, or splitting into 2 orders that you play with. And by moving the laser beam over the apertures, in this case, simple mechanical translation would do, you can get different power to the ring or the center. Or for example, if it was double spot welding, you could get more power to the right spot or the left spot. A lot of variability is possible. Basically, you can also do this with rotation in a different DOE. I'll just show you a short video of how it works. One sec, it's very slow, so let's adjust the speed a bit higher. And here it is. Here I'm moving, this is me moving a DOE. And you can see on the screen in the camera that basically we can move the ring mode versus the central core at any ratio from 100 in one state to 100 to another. And basically this allows one to achieve complete tunability with beam shaping without the need for any specific laser. You can just buy a multi-mode fiber laser, a relatively low-cost investment relative to other types of welding lasers, and by simple integration with such a static component and one computer controlled axis, you can achieve the same functionality of adjustable ring shaping that is highly sought after in the welding and cutting application fields. Thank you, Jose, for your time, and I would love to answer any questions if there are any.
Thank you very much, Natan. Thank you for this, and thank you for keep innovating constantly on the field of DOEs. Today, welding. I have a lot of members here who want to do business with you. Yes, think about companies like Trumpf, like Laserline, like IPG. So these companies, what can you do for them? What can they do for you?
So of course, we would love to help them with their shaping needs, including help with a specific design for specific distributions for processes as they define, because they know the processes better than me. And for us, what they can do is provide the ground for especially publishable results of this sort of adjustable shaping. We're always looking into cooperation with integrators that are willing to share this data afterwards. Can be a European project, can be directly with them. This way we have proof for our customer that these processes work. And as you know, it's always hard to get this sort of data in this field.
I love the DOE shaping that you have behind you. That's fantastic. What would you tell those companies when they ask you what's new?
So I think this was quite clear here. The new thing is that you can take a passive component such as a diffractive optic, and by simple adjustment like rotating or shifting or even scanning through it with a galvo, you can get multiple functionality out of the static component. So
I have a question in the room. René from TeraXion, what's on your mind?
Yes, I was wondering, what are the compatible beam quality for the input of these beam shapers?
Yes, so basically we cover the whole range. I mean, we have some shaping solution for single mode, but the one that you saw here, this concept is of course designed for multi-mode fibers, usually a core for 100 microns or more. Their M square is around 12 usually, or more than that, 24 could be. So they are not harmed in terms of the spot size when you do this sort of shaping to them. You still get diffraction limited performance for this sort of laser.
Thank you.
Thank you.
Thank you very much, Natan. Thank you, René. Thank you, everyone. We go to the next one. We go to our EPIC member. Looking forward to find cooperations in germanium-based 6-inch wafers, Umicore. Let's understand how we can help them. The floor and the attention of everyone goes to Bendix, goes to Umicore, goes to germanium wafers. The floor is yours.
Hello, Jose. Thank you very much for giving us the opportunity. And also thanks to everybody else for joining today. Let me share my screen here for a second, see if it works. You see it? Is it appearing?
It's crystal clear.
Okay, great. So this is a bit of a strange or a different presentation because we're not really presenting an actual finished product. We're talking about actual basic materials. So VCSELs have been made on gallium arsenide for as long as I can remember. And now germanium has been proposed as an interesting alternative. So let's go through this slide deck here to see why is this happening. So, well, first of all, who is Umicore? Because you probably have not heard about the company. It's a mid-sized Belgian company, about 3.4 billion revenues, about 11,000 people. We are focusing on sustainability simply because we are the connection between the planet Earth and the resources on the one hand, and the materials and the finished materials going into the products. So we need to be aware of where the materials are coming from, ethical sourcing, all of these things are very, very important for us. We are strong in catalysis, which is, well, what you can think of automotive catalysis in your car, catalytic converter. We are very strong in lithium-ion battery materials. So you can see that there is this environmental element in everything we do. We're also very strong in recycling of precious metals. This is an activity in Belgium which is pretty strong. So where is germanium fitting in? Germanium is fitting in the middle part here on the energy and surface materials. Why is that? Because germanium has been used for the last 20 years as a substrate material for solar cells used in satellites. And it's a triple junction solar cell, so very efficient solar cells. And actually, satellite business is the most important one and interested in this technology because it's rather expensive. It's using epitaxial growth of gallium arsenide layers onto germanium. So it's much more expensive than silicon. And in space, lightweight, very efficient cells is still very important. So you can hear something I've said is very important is the gallium arsenide epitaxial growth on germanium, which is also the basis for VCSELs. So why has it been used for germanium? Because originally it was also on gallium arsenide, the solar cells. So why did they shift to germanium? Well, first of all, germanium adds an additional junction at the bottom for infrared. So it gives some additional efficiency. It's also stronger than gallium arsenide because it can be made much thinner. So our wafers typically go at 145 microns thickness. And you can have sizes which are much larger than in gallium arsenide. Basically, germanium wafers are defect-free up to 12 inches, very similar to silicon. So I think these are a few important elements that are also becoming more and more important for VCSELs. And that's why we believe, that's what I put here in the middle of the slide, is germanium is really going to blow the gallium arsenide out of the water. I understand this is quite a statement, but there is reasons to believe that that this is going to be an important evolution. And so let me go through why. As you know, a VCSEL is made out of two Bragg reflectors with active layers in between. Now, the Bragg reflectors are typically made out of gallium arsenide and a combination of aluminium arsenide and gallium arsenide, aluminium-gallium arsenide. If you're looking at the lattice constant, the lattice constant of the combination of those two materials is actually spot on germanium, but it's not perfectly matched to gallium arsenide itself, which means if you grow thick DBR layers, you see that at the graph at the bottom here, that you have quite significant bow in your wafer during growth, which means that you have issues with your uniformity of your growth on gallium arsenide, which on germanium, you don't have any growth at all and bow at all. And what you can see here is this is work being done by IQE, and they have made an announcement last week on this work. And so this is a work that's been going on for the last 2 years. What's important also is that this bow creates some issues in the processing, yield issues at the processing further downstream. And this has been calculated to be more than $500 million a year across the industry of yield losses that can be improved by using germanium. Another point which is important is the dislocations. I mean, the limitations of gallium arsenide are the fact that you have certain dislocations, you have unmounted dislocations, and the bigger that the surface of the wafer becomes, the more difficult it becomes to control the amount of dislocations. That's why 6-inch is already a stretch. 8-inch is becoming very difficult. As I've mentioned, we don't have any dislocations. So if the industry wants to move to larger size, for instance, by making bigger arrays, bigger VCSEL arrays are going to be needed in LiDAR applications, for instance, for autonomous vehicles. There, the bigger size of the wafers are going to become much more important, and that also germanium could be an interesting solution. And then as a last part, I mean, the environmental element is also very important. To move away and to have a good thermal evacuation of your heat, you have to grind down your wafer, your substrates for big arrays because of the heat. And of course, grinding down gallium arsenide is not very environmentally friendly because of arsenic. Germanium can be recycled. Basically, you can eat it. I mean, it's very, very safe to use. It's very easy to recycle. So in the manufacturing of the VCSELs, this is also a significant element as environmental things become more and more important. So this is basically the storyline. Why? And I'm sure you have these questions. So if this is so obvious, why has this not happened before? And one of the reasons is until relatively recently, let's say with Face ID of Apple, before that, VCSELs were used in the telecom industry, and the VCSELs were relatively small. With VCSELs becoming more important in 3D sensing, so 3D sensing and LiDAR, the power of the VCSELs have to go up. And the only way to do that is to have a 2D array of VCSELs, making bigger and bigger dies. And so until now, gallium arsenide 4-inch was perfectly fine. There was no reason to go to germanium. Now with the arrays becoming bigger and bigger, gallium arsenide is really running into its limits, and germanium is here to rescue the industry, let's say. Maybe that's a bit of an exaggeration, but we believe really in this solution. So I thought let's keep this short and sweet. So the wafers are available for purchase. Another reason why, I forgot to mention, one of the reasons why it was a bit difficult is the mobility of germanium, mobility of the charges is less than in gallium arsenide, which means that you have to add much more dopants to your germanium in order to come to a low resistivity that is needed in the VCSEL production. So we had to find and develop a technology to increase the dopant levels in the germanium to come to the same resistivity levels as what you have in gallium arsenide, which also was something that took us some time to get there. So all of that is now ready for commercialization. So if you want samples, if you want to buy those wafers, they are available. If you use your smartphone, you can scan this 2D bar and get in touch with us right away.
If you want samples, they are available. And just to remind everyone, if you want samples, and ask me, because I will pay for the shipping expenses between members. I love when members collaborate and exchange samples. Bendix, I have people like Lumentum, Finisar, Osram, all of them watching what you can do. What can you do for companies like 26, and what do you expect that they can do for you?
Well, what we can do for them, you've seen the yield losses and the cost that they have. I'm sure that they're under constant pressure by their customers to bring down the price of the VCSELs. So by using germanium, potentially the cost is going to come down significantly. What can they do for us? Well, spread the word. Honestly, this is a perception issue. Nobody knows what germanium is. It's completely unknown. The first transistors were made on germanium. Everybody knows that. But after that, the material disappeared off of the face of the earth, so to speak. So, I mean, in space, nobody talks about solar cells for space. So this is really the time for us to really go out there and let people know that germanium is really a valuable solution for this.
CMOS foundries love germanium, so that's clear. They love it. CMOS compatible. They
Silicon
can put thin
germanium,
layers and actually put them as an interface for lattice mismatch materials. When it comes to company, for example, like ST Microelectronics, that is investing on depositing germanium on a CMOS plant, what kind of added value would you say we have to work together? Because with Umicore, you can do.
Yeah, so the amazing thing here is that we're developing a thin film technology. which would be interesting for ST microelectronics for instance, detectors. I mean, if you want to make sphere detectors, this is something that we're looking into to developing with them. But it's way too early to commercialize that. But it's a development effort we're currently involved in. Is in thin layer germanium to be a substitute for silicon germanium or germanium grown so onto silicon, having too many defects. This is defect-free germanium.
Now we go all together to look at the moon. Luna Innovations is the next speaker. They're going to talk to us about distributed temperature measurements. Thank you very much for being with us. You are the last presenter of this epic product release session. Send us off the right way. The floor and the attention of everyone goes to the moon, goes to Luna.
Thank you, Jose, for that introduction, and thanks as well for the opportunity to speak to the group today. I think my slide's coming through. Okay, so so I want to talk today about an exciting new development in the area of our distributed temperature sensing. Basically, kind of moving the technology forward with some new methods that really improves the accuracy and the usability of our temperature sensors and temperature sensing capability. So real quick, a little background about Luna. So we are headquartered here in Virginia, and as you can see on the map, we have worldwide locations and support. We're not a newcomer to the world of photonics. We've been in photonics technology for several years. Went public in 2006. There you can see the size of our organization at this point. We have one arm of our business focuses on government contract research. That's the Luna Labs segment. And then what's referred here as a Lightwave is our product segment, which of course makes up most of our business. So looking at our products organize into two basic segments. First is fiber optic sensing and NDT or non-destructive testing. So this is fiber optic sensing, which I'll talk some more about, as well as we have some precision gauging and imaging systems that's based on terahertz technology. And then on the other side, we have our communications test and photonic control platform. So here we have a number of test and measurement instruments, which are really geared towards testing and characterizing and analyzing fiber optics, fiber optic networks, components, characterizing optical components such as integrated circuits. We also have a growing capability here in the area of polarization management. Just a week or so ago, we announced the acquisition of New Ridge Technologies, which really expands our portfolio of polarization control and polarization management modules and instruments. So that's there as well. But today I want to focus on the fiber optic sensing side of the business. So we switch to the left side here. We have two product platforms on our fiber optic sensing side of the business, a high definition distributed system and a high-speed multi-point system. This high-speed multi-point system is based on fiber bright gratings, which you heard a little bit about from FBGS earlier today. So that's our Hyperion system. Some of you may be familiar with the Micron Optics brand. So they joined the family a couple of years ago. And so we have a whole range of FPG and Fabry-Perot sensors and measurement systems based on that technology. What I'm going to focus on today is the one on the left, our high definition distributed fiber optic sensing platform, which is based on analyzing the naturally occurring Rayleigh backscatter in unaltered fiber. And we've really refined the process over the last several years such that we can measure temperature and strain with super high resolution down to less than a millimeter along a fiber. So looking a little bit closer at our distributed fiber optic sensing platform. So this goes by the brand name of Odyssey, ODISI, stands for Optical Distributed Sensing Interrogator. So the way this system works, I guess in a very simple way, is we interrogate an unaltered standard fiber, analyze the Rayleigh backscatter along that fiber using the Odyssey system. And from that, we're able to discern individual strain or temperature measurements along the fiber, like I said, down to 0.65 millimeter spatial resolution along the fiber. The Odyssey system itself, we offer that in anywhere from 1 to 8 channels, and each of those channels can support strain sensors as long as 50 meters in length. And then in there you see an example. A lot of our customers use just very simple polyimide coated fiber optics that we offer a variety of these just to maximize the transfer of strain to the fiber. So I mentioned that this technology measures both strain and temperature, and there you can see some example data. With this system, you get a very high resolution profile of the strain or temperature field. Now that gets to one of the challenges with this technology is that if you know anything about Rayleigh backscatter, that it's sensitive to both strain and temperature. And so when you're trying to make a distributed temperature measurement, for example, any strain that sensor happens to be incident on the sensor will directly show up as an error in the temperature measurements, and it could be very large in a lot of standard applications. So the new development is we've developed a new technology and a process using our Odyssey system for measuring temperature and essentially removing the effects of the strain on the temperature measurement. So the result is a more accurate, more robust distributed temperature measurement with high resolution. With this system, we're able to have a measured temperature with a 1 centimeter spatial resolution along the fiber. There's two pieces to our solution. So there's the actual sensor, which today we're offering in this package. It's pretty much kind of similar to our other sensors, polyimide fiber loose in a small Teflon tube. And then we're also, as part of this, releasing a whole new family of Odyssey interrogators that have most of the features of our standard Odyssey family, but are optimized for this more accurate distributed temperature measurements, and including a lower price point to make it more accessible for a lot of these temperature applications. So kind of to summarize the benefits in the applications, again, this high definition distributed measurement capability is very powerful, but you tend to need to work around the fact that it responds to both temperature and strain, resulting in quite a challenge when you're making distributed temperature applications and attaching the fiber to, say, a curved surface, as you see here in the bottom left, or snaking a sensor through a battery pack structure, as you see here. Those bends and curves tend to cause mechanical strain on the sensor, which again in normal sensors would result in large errors. With this new strain compensated temperature sensor, essentially removes that effect, and you can make those measurements with more accurately and without worry. So that's kind of a quick summary of our new temperature measurement capabilities. Again, I encourage you to go to our website. We have information on the Odyssey and distributed measurement system and our other sensing applications as well. That's
Thank you very much, David, for this. Imagine, in EPIC, I have companies like ASML, Trumpf, Prima Group, PVF. What could you do for them? What can they do for you? And when they ask you what's new, what would you answer?
Okay, yeah, great question. So yeah, in terms of what we could do for the other members of EPIC, I think we have a full portfolio. In addition to measuring mechanical and physical properties, again, what I didn't talk too much about today is we have this full platform of optical analysis and characterization tools for developers of photonic systems to look at distributed loss, to look at polarization, and do very unique types of characterization and analysis of those systems. So we offer a number of tools. Encourage everyone to check those out. on that side of our portfolio in terms of what members can do for us. I think on the sensing side, again, I showed just one sample of a fiber sensor, which is basically optimized to be as small and flexible as possible for those type of applications. Other mechanical and packaging applications of the fiber for different sensing applications is probably one area that would be beneficial to us and our customers.
David, first of all, I would like to congratulate you for the amazing collaboration between Somni, Silex, GHT, and Luna Innovations on monitoring the Genoa bridge. Before the COVID-19, we were all worried about that beautiful bridge in Genoa that fell down thanks to companies like you, and the collaboration with EPIC members. It's not going to happen again. Oliver, after this presentation, is there something on your mind as editor-in-chief of Photonics Views?
I'm just sorry if I missed something. I had line problems down a couple of the last talks. Question to Luna. You were showing an application where you have the fiber in a battery pack. So would that something that electromobility should be looking forward to monitor temperature changes and look changes in the battery packs?
Yeah, absolutely. That's that's why I kind of had that graphic there. Is that's a key application where we're talking to a lot of the designers and manufacturers of battery packs, because today they're using traditional for these types of tests and characterization of the thermal properties of their systems. They're using thermocouples, and of course we metal wires and the bulkiness of the cables. Now, if the very single hair thin fiber, they can get lots of temperature measurements, very low thermal mass. And so, yeah, it's a really good match for thermal characterization of battery cells and packs in particular.
It is great to have companies like Luna or like all of you together with us. All you have to do now, after hearing all these technologies, is to make sure that they have value in your business, because it's all about cooperation. The most important, you need to hear the presentations, is the follow-up. If you want to get in touch with any of the participants today, send me an email, jose.porto@epic-asset.com. It's no work for me. I actually do this for fun. I love introducing companies. Be aware, we keep organizing fantastic meetings. Anytime that you want to participate in any of the meetings, go to our website, epic-asset.com, and register. Do not complain if you missed it, but if you do, remember that we also keep them in YouTube. On behalf of the dream team of Photonics, on behalf of a fantastic group of colleagues that I have at EPIC, all I want to say is stay safe, be healthy, wash your hands, and be EPIC. Take good care. From Noordwijk, the Netherlands, bye-bye. Thank you very much for a great session. I think we are offline